But you know what gets easier? Making things the default, like open sourced it. We started, like end of the 90s. Things were shareware. You would get software that you could try about 95%, but for the remaining fun parts, you had to pay a couple of dollars, and then you got it. And it wasn't open source. We couldn't learn from each other. Fast forward 20 years, it's the default. No matter if you're a single-person team or a team funded by a company with tens of thousands of people building on the product that you're working on, it is now the default to do it in the open and to share it, often with licenses that allow you to modify, to commercialize, and use it in any which way. It's beautiful. It's so beautiful that your car's navigation interface, if you're driving a BMW anyway, your container images, of course, your browser, your JavaScript frameworks, they all have open source dependencies. TypeScript projects generally clock in at 96%, others only at 90%, but even that, think about that for a second. An application with 200 dependencies, 90% of which are open source. That is, you're standing on the shoulders of giants. And that's, I think, absolutely beautiful. And they're all in your repositories. As an engineer who likes stuff to work, this is a bit of a problem. Because everything that's in my repository, everything that goes onto my infrastructure is a risk I have to deal with. As a site reliability engineer, I don't like to be paged. This is very important. I know it's part of a job description, but just like nobody raises their hand for security, I'm not going to raise my hand for wanting to be paged. So, quick intro. My name is Kerim Satirli. I'm a senior developer advocate at HashiCorp, where I focus on infrastructure and orchestration tooling. Basically means I get to tell people about best practices, how to implement them, what to do, what not to do. And when you do it and it breaks, that's all on you. It's like a platform team. It's beautiful. If you have thoughts about this presentation, I'm at Satirli pretty much everywhere. If you have recipes for good chocolate cakes, I will definitely take them. This is very important. So I want to start out by talking quickly about software delivery life cycles. We'll take a modern one. We're going to simplify it. There's not going to be UML because I'm not a consultant. So we're going to make this very simple. Step one, we develop. Usually, you join a company, you get a high-powered MacBook. That's great. Your screen and keyboard will get dirty and, of course, no longer look very Apple. But that's where you develop. This is your machine. You're proud of it. And, especially these days, maybe you're actually using it on your iPad because, hey, we can work from everywhere. Thank you, COVID. Literally the one good thing that came out of it. Then, build environments. Some of us still use Jenkins. Others use even more archaic tools. The modern crowd, GitHub Actions, GitLab runners, it's beautiful, right? We've got this all pretty much packaged up, usually containers everywhere. And then we build something. Maybe we're compiling 16 megabytes of text files into a single JavaScript file that ends up on Cloudflare. Maybe you're doing something else. Maybe we're building actual applications, binaries. It all goes somewhere. And this is critical because once we have that somewhere, we can run it. I work at HashiCorp, so of course I run my stuff on Nomad, but you can also run it on Kubernetes. Doesn't matter. This is about patterns. This is not about one specific technology. Everything I'm going to tell you today, you can apply to pretty much everything that we've talked about today. This is important. Once we get to the running stage, business people get happy. Our application is live. It's making money. It's also costing us money because people are monitoring it, but hopefully you're selling more than you're spending. This is critical. But all these things, develop, build, store, run, is it really about those? Or is it about something else? It's about this. It's about trust. It's about building a relationship with every stage of your software delivery lifecycle and figuring out how to maintain and nurture that relationship. I'm not going to make you clap because it's not that kind of relationship. But I want you to think about this from an engineering mindset, from a business mindset. What your application needs to go from all the way left to all the way to the right. Then I'm going to try to piss you off a little. When you bring 94% of your dependencies in from the internet, and you just pull down everything that you can, there's an XKCD for that. Everyone knows the Node.js module joke of you're basically pulling in 98% of the internet. You're pulling in a lot of great work from people you don't know. And for those of us that worked in companies that did forced team building events like trust falls, doing a trust fall with somebody you don't know is not a good experience. You will quickly learn not to trust them. I do want to point out this has nothing to do with OSS. This is everything to do with code. Anytime you pull in somebody's code, no matter if that's your team or somebody in Nebraska who's maintaining this one library that the whole internet depends on, that's a risk. And the reason for that is real simple. You don't know. We're all smart people here, right? I guarantee you nobody here can figure out how a cryptographic hash function works, not for an interview and not without any source material. Because it's hard. None of us are meant to be as smart as all of us together. So how do we stand on the shoulders of giants? How do we make sure we can win a little more? I don't do light code. I don't do light slides. I do the stuff that makes you hopefully think. And as somebody who does a lot with risk management, I assume hostile intent with every piece of code that is handed to me. Usually, the junior engineers don't know what the shit they're talking about. Stuff that comes from the internet is broken. And I have to fix it. I hate it. Good thing is, there's smarter people than me that help me figure out how to do this. So we're going to look at 4 things real quick in ways that we can solve this. And I want to start out with this one. Who here works for a company that has more than 500 people? Raise your hand real quick. Does your company install endpoint protection software that helps the company make sure your laptop is up to spec? Yeah, we hate that, right? They always somehow forget to put us in the super user groups and make sure that things work. But we're smart people. We fix this. This is very easy. Of course, it gets reported, but you block the outgoing firewall, and then it's like, oh yeah, sorry, I guess my home network is really bad. IT eventually walks away, and you create a new problem for them. So I want to start out, when we're talking about securing development, start by securing your laptop. When 1Password tells you, hey, there's a 2FA available for this site, use it. The reason for that is real simple. Your laptop has access to your company's infrastructure. Let me rephrase that. Your laptop is part of the company's infrastructure. I have keys on here that allow me to generate licenses for our clients. I have keys on here that allow me to tank some of our production environments. Generally don't do that, but my laptop is part of that, which means the risk surface extends to currently Frankfurt, which our compliance team was very excited to hear about yesterday. So how do we go about this? We're going to do 3 levels. These do not map to job seniority. You can do all 3 levels as a junior engineer. You can do all 3 levels as a senior engineer. The more you do, the better your life gets. So level 1, we joked about this in the panel. Anytime you bring in engineers, they're going to have a rule set, right? Write that rule set down. If I know what this team expects of me, that's a great first start. Then use your 20% time to codify those rules. Let me verify locally that my stuff is good before I push it up for the team to review. This is important because everything that I test locally, I can skip. Once it runs remotely, it gets a little harder because there I can't omit it. And then because we want to manage risk, we want to make sure this device is the one that sent it, which means we want to make sure my user was used for this. Make sure all your stuff is cryptographically signed. Doesn't matter if you use signed Git commits with PGP or something like GitSign with OICD provided identities. Make sure your stuff is signed. It's cumbersome, it's not fun to set up, it's useful. And then, especially the smaller companies will have this problem. You get added to a new organization, you get that beautiful email on the first Monday you're joining the company. It says, hey, you've been added to this organization and you're part of the core team. Great. Admin on every repository. Love it. Review settings? Oh, no, not for me, thank you. Remove that quickly. You don't have to be a senior engineer to do the right thing. Culture, security culture, and any culture is a byproduct of consistent behavior, right? If you do things the right way when nobody looks, you're being a better engineer. Surprisingly, also a better human. And then, for those moments when you're tempted, make sure you have audit logs. Your company is going to grow and get to that stage where you need to prove that nothing untoward has happened. Much easier if you have audit logs there for that. That went just a hint faster than expected. So we've secured our local development, we've secured our VCS. Let's talk about protecting builds. I'm a huge fan of GitHub Actions, but this works for Jenkins, for everything else. And we talked about signing our commits, right? The reason we want to do that is because we punish people who don't sign them by not running their builds. Oh, my code ended up, but the build server didn't kick off. Yeah, because you didn't sign it. Because we don't know it's coming from you. We don't know what the attestation will be like. Then, of course, your build server is eventually going to get compromised. Every vendor will tell you, we can secure stuff 100%. As somebody who works for a vendor, I can tell you this is a lie. None of us can do that. That's okay. We can shift it all the way to the left. And we can account for a lot of this by, for example, codifying things and making sure they are tested in different environments. And this is the easy stuff. When we go one level further, that was 2 levels. We want to make sure that all the build logs we create are tamper evident, which means we create a build log and we have like 6 megabytes of text information, right? Nobody's going to put that through encryption and decryption every time. Get a checksum, put that in a durable storage that is hard to modify, or impossible, preferably. Boom, you've got tamper-evident build logs. If you have a lot of storage, put the whole build log in there because it becomes tamper-proof. Again, good for auditing. If you're in the financial industry, healthcare, anything, a lot of high-volume, high-performance industries need this to work. And then, of course, your build server is only as strong as the stuff you run on it. If you run a test with something like Nginx latest, congrats. You created job security for somebody else, definitely not for yourself. Full content addressing. It sucks, right? Because Nginx latest, 12 characters, something like that. I'm bad with math. Having the same thing explained with SHA-256 checksum balloons this whole thing up to 40, 50, 60 characters. That sucks. It's no longer human readable. But it is very, very identifiable, which means what I get today is going to be the exact same experience that I get tomorrow and 6 months from now. And tampering becomes evident. And then, of course, when we're building, why not create a list of the stuff that's in there? Containers, especially a great place. Shipping containers that go onto ships, have a little piece of paper attached to them. These days, it's a JSON blob in an API somewhere, but the principle is the same. Contains a list of everything that's in there. We want to see from the outside what's in there, because that means when there's a vulnerability, like somebody deciding that today is a good day to get arrested and I can no longer maintain my project, means I can now remove that dependency and solve that problem for me. And while you're at it, make sure your builds are hermetic, which means no dependencies pulled in at runtime. All your application servers will happily do an npm install at runtime. That's great. Makes your build really small. Also makes your build really fragile. If you truly hate your site reliability team, definitely do not put the dependencies in there. Let them pull them in at runtime and see how they deal with it. If you want to show leadership, have your build artifact be a single thing that contains everything that I need to run. Because that means I can establish what's in there today and trust it. Then, when we have all those artifacts, let's do something fun with it. We're going to sign them again. Big surprise there, right? The reason we sign them is because anytime we can prove a chain of custody, we have something that works. We have something that we can refer to and see what's in there. And then there's the other thing, especially in the container world. This is a fun one we came across. Same build pipeline, nothing changed. Couple of base images. Somehow decided to add a little more in their base tooling install. 200 megabyte container suddenly became 2 gigs. Nobody noticed it until we started noticing that the deployment times ran up. Because pulling in 2 gigs, even on something like Amazon, takes slightly longer than 200 megs. Our monitoring picked that up, didn't pick up that the container size had gone up by 900%. All right, well, we can fix that. And you don't have to be an observability genius to do that. You can do that today. If you use something like Datadog New Relic, there's a very simple query for that. Pop it in there. It's going to be the one check that never triggers until it does. And when it does, you're going to be like, man, I love this. While you're at it, isolate your build and artifact servers. Anything that serves production workloads and has production artifacts should never be able to also get stuff that's not for production, because they serve very different use cases. Anything for staging, anything for testing, development, I don't care what people do there. For production, I need to be sure that whatever is on there is safe, because when we do rollbacks, I kind of want to know that I can trust it. And then, of course, as before, make sure you limit your admin access to the right audiences and only the groups that really need access. Senior engineers like to say, oh, I need access to that. That's why I add myself to the super user group on my Mac. You do not need access to everything and every system. My personal favorite here is making sure all your dependencies are allow listed. This is hard. Standard application, 200 dependencies, you're going to have a lot of allow listing to do. You can't do that manually. You need tooling for that. Build tooling for that, buy tooling for that, doesn't matter, just do it properly. And then make sure you scan those dependencies when you're in production. Because just because a container or any image is deployed doesn't mean it hasn't been tampered with. You cannot trust anything that happened in the previous steps, even if it's cryptographically signed, because new bugs pop up all the time. And finally, we're here to talk about orchestrators. If you're deploying in a cloud and not in your own data center, the shared responsibility model is a huge thing. It's a whole different talk, but think about what it means to share your hardware with other people. And then please close down the management interfaces. You do not need to access Cube Dashboard or, in our case, the Nomad UI from everywhere on the planet unauthenticated. If you do, maybe IT is not the right job for you. GitOps, right? Don't allow human interaction for production workloads. In the build server, yes. In the deployment flow, yes. Reviewed by other people, sure, but the ultimate deployment should be done in an automated way and codified way. Very, very important. And while you're at it, remove all those hard-coded API credentials. People think, oh, it's just Mailgun, right? I mean, how expensive could it be? It can be very expensive. Then, personal favorite is always making sure your hardware is the right size. This is hard. You can be in cloud computing for 15 years, 20 years, and you will still get this wrong. Monitor for outliers. Monitor and make sure what you're seeing there is actually what you expect it to be. If you have a web application, you know how much CPU and memory you need, right? It should be easy to figure out how much your workload should do in production. And then finally, and this one I'm going to say is a caveat because it depends on the industry you're in, fail securely instead of safely. We had a client who failed their website in a way that when they couldn't retrieve a coupon code and verify that the coupon code was actually working, they would default to 15% off for everything. It's a beautiful story. I think we still have not gotten permission from them to share who they were. Failing safely, their thought was like, well, customers should still be able to buy. Sure. Do you want to give 15% discount on everything throughout the year? Probably not. Think about how you can fail in a way that doesn't hurt your organization. 20 minutes is way too little time to give you all of this in code. So head on over to github.com/workloads. I've got pretty much all of these patterns codified there. It's going to be using Terraform because that's my second language. If you need a QR code. And then in closing, I want to leave you with three thoughts, three very short thoughts. The Romans figured this out 300, 400 BC. Defense in depth is the only defense that works. You can't have a single layer because a single layer sucks. If you're a climber, you know you need multiple layers because that's how you keep warm. Layers require people. None of us are as small as all of us. You can be the lone hero that pushes your organization forward and helps showcase, this is the way we should be doing it. That passion is good. But just like the single contributor that we had, you will eventually burn out on that. So don't do it. Security is ultimately not a one-person thing. It's not a one-team thing. It shouldn't be them. It shouldn't be those people. It should be all of us. Because it's the only way that we can make this work. And with that, you've been amazing. Thank you for listening. Yeah, I'll take one question because that's all the time we have.
Yeah.